towards the end we were talking about something called data warehousing architecture. So architecture meaning how we are going to set up data warehousing in our company. So I will do that quick review of that last topic, and then inshallah we'll continue from there. Okay. So architecture, there were a couple of things we were discussing. One of them is how we are going to put them together. So we talked about 2-tier and 3-tier architecture, whether we would like to keep the database, the data warehousing, and the client separate. But most importantly, I would like to start talking about this because this is where our discussion will continue. Okay, from here and onwards. So if you remember from our last discussion, there are various options available to us. If you want to set up data warehousing in our company, one of them is called independent data marts architecture. So if you remember, we said that in this particular option, we can have sources, we can have data processing, but then we keep separate data marts for each part of the organization that needs it. For example, an independent data mart for finance department, an independent data mart for marketing, an independent data mart for supply chain and so on. So you understand that? But they are all independent, which means that they are standalone. They are not connected to each other. Then we said that there is another option which is called data mart bus, and where we said that the same data mart, they are in this combination, they are standalone, but they are linked as well. They are connected to each other, right? This is what we said. They are connected to each other, which means that they can access each other. But they are all still like they stand on their own. But then there was a third one, which is called hub and spoke, where we have a central command kind of main relational database. Whenever I say relational database, you need to think about the databases that you studied in MIS 309. The ones with relationship tables and everything, right? So those are that database is in the center, and then you have those other data marts around it. So they are feeding from this main database, right? So these are the small data marts. Is that clear? This was from the last time. Independent ones, connected ones, but then there's like a main database around which all small data marts are arranged. Then we have we don't have a data mart, rather we have like a normal database that you have studied. So this could be another option. So you take whatever data you need directly from the database, and then the last one we studied from the last one was called federated architecture. So you remember I was giving you example about United States, and they have their own independent states, and right? So federated databases are where you have data marts, databases, Excel files, other data sources. They are all independent, and you access whichever you need, right? But they are all available to you, different data sources. So this simply says different data sources, and then you directly use them to use. You don't have any, you don't see any data mart here. So is that clear? Different options. But the question that you should ask now is which of the option, these 5 options that I showed you at least, which one do you need to use? Which one is suitable to you? Okay, so that should be a question that has to be asked. So there are 10 important decision selection criteria that you need to look at to pick whether I need to go for independent one, the bus one, the star one, and whichever of these 5. Okay, so the first one is information interdependence between organizational units. Interdependence meaning that their company has different departments, right? Finance, marketing, supply chain. How much they are dependent on each other in terms of information. If they are not dependent on their information, as you can imagine, maybe independent data marts are fine. But if you are heavily dependent on each other, you need to have a connection between their data marts. Do you all agree with that? Right? So you have to argue like that. You have to think that because of interdependence, maybe going like this may not be very suitable, because then how would you get the data? Maybe you need to have something like this or something like this will be more helpful. Okay, so interdependence is one important aspect that you need to look at. Upper management's information need. So if upper management is looking for information from all of them, maybe a common database is what is more suitable, right? So again, you have to see this as an important aspect to look at. Urgency of need for a data warehouse could be another thing. Nature of end user task. Constraints on resources is again a very interesting thing. Different architectures can cost you different money. For example, one architecture, maybe the simple independent data marts might not be very expensive, but when you're creating connections between them, maybe it will cost you higher, right? So you need to also see how much each of the option will cost you, because your company has a certain budget within which they have to create a solution, right? So maybe sometimes even your budget can dictate these things. Strategic view is simply saying that you might be designing your data warehouse for a long-term purpose. So you just have to see which of the architecture is helping serve that purpose. Compatibility with existing systems, the term compatibility, right? You already have some databases in there, so you'd like to see whether they are compatible with them or not. Even as simple as your staff is capable of designing that architecture or not. Perceived ability of the house IT staff. I have a person, is not very capable to create a complicated data warehouse, right? So I will not be able to do it. So I need to go for a simple option. So technical abilities, technical issues, social political factors. Social political factors are mainly, things like there are always, whenever you bring something new, some people are affected by that decision. So you will always see in the company that some people will like it, but some people will not like it. So there will always be some politics going on which will create resistance to solution. They say no, we don't need data warehouse, things like that. So this is just an example. So let me just continue my talk about that. So whatever data warehouse you create, one of the major things that we have already discussed, but now we'll go a little bit more in detail, is called data integration. What is data integration? What is the meaning of the word integration? It is integration means to bring things together, right? Integration means to add, to sum up, to combine. So integration, as you can imagine, is always there whenever we talk about data warehousing. So the general term is integration. ETL is just one method of integration that is used, but there can be other ways. But ETL stands for extract, transform, load. We'll talk more about it. So, but integration in general have three important aspects. Data federation, meaning that you have to identify different sources. I just showed you federation, meaning like many independent sources, right? So you have to look at sources, how to access them, and then how to capture changes between them, because there can be changes across databases. So you have to make sure that you deal with the change. And change meaning that different units used. For example, one is using meter as a unit of length, the other is using inch, right? So you have to make sure that you deal with those situations. Now, another, in terms of integration, there are two levels. One of them is called application integration, and the other one is called information integration. When you are trying to take the source, the whole big data, a lot of data, and put that, you're trying to bring it into a system, we call it application integration. See what it says: a technology that provides a vehicle for pushing data from source into the data warehouse. So you take it from the source and put it there. So what is information integration? It is usually, I think, as I understand, comes after that, but the key word here is real time, meaning that you already have a data warehouse, but you keep adding in real time, the new information. So you can see here, it's evolving tool which means that it keeps evolving, it keeps happening, and it promises real-time data integration from a variety of sources. So you bring a lot of different real-time information into the data source. So one is the whole system, you bring it into the data warehouse, and then this one is like you bring the data in real time. So let's just talk a little bit more about the ETL, extract, transform, and load. We already have talked about that. So you have a lot of different systems. You extract data, but I talked last time as well that you have to transform. So why transform? Because they can be in different forms. Date. Have you seen dates in different data sets in completely different way? Right? Some people are writing month first, some people are writing like days first, right? And then even the way, the format, it's like slash or dash, there are different ways. Even if you go to Excel, there are so many ways dates can be written, right? So have you done this in Excel, and when you change the format of the date and it starts showing it in a different way, right?
Yes.
So same thing. So you have to transform, you have to put them in the same, because one data set using one format, the other is using another format, so you have to transform. But last time we did not pay a lot of attention on cleansing. So what is cleansing? What is data cleansing? What is the meaning of the word cleanse? Okay, so what do we mean by cleaning the data? Cleaning what?
If you have duplicated data?
Yeah, so I'll give you an example. So I was working on, me and some of us were working on a project with Ministry of Interior and police and Red Crescent about some accident data. So they asked us, all these Sahid camera and all these penalties. So they started working on a project 10 years ago, and they bring all those policies, and they wanted to know, has that reduced number of deaths in the accidents. So they wanted us to analyze the data. So we had this data that came from Red Crescent, from police, from hospitals, and all different sources, so many sources. And we started analyzing, and then we did not pay attention to cleansing. And then at a later stage, we realized that this data looks the same, right? So a lot of data was duplicated. Why? Because the same case was reported in police, the same case was reported in the hospital, and then put together. The number of accidents were far more than what they actually were, simply because there were a lot of data duplication. So we then went back, we said, well, we forgot to do data cleansing. So we had to remove all the duplicates. Not only that, there were some strange numbers in there. For example, age. 300 something written as the age. You can imagine that it must be maybe 30 something, maybe like there was a typo during entry error, right? So we had to fix all those errors. We have to check if there's any other problems like that, right? So cleansing is important, because your decision later, your analysis is as good as your data. So if your data is bad, imagine we had like 1,000 extra duplicate entries, so we would have reported 1,000 extra accidents, which is not the case, right? So all the results are affected by that. So cleansing is important. So transformation, we did, of course, transformation. We had to do a lot of transformation in terms of dates and in terms of many other things. Even we found errors in city names. So sometimes we had to group how many accidents in a city, but when we discovered that there were like some errors in like city names and so on, so we fix all those things. But this was just a practical example of ETL. We extracted, we transformed, and then we loaded it into a single data set. Okay. Now, issues when it comes to ETL. The good part is companies can buy softwares that can do ETL for you. There are some softwares which can do ETL for you, so you don't have to like write a Python program, or you don't have to do it in Excel manually or something. So there are very good software that allows us to do this ETL. So what are the issues that you have to look at? The prices can be a concern. So you have to find, you may find some very expensive ETL software, expensive ones, okay? So expense could be an issue. Maybe you're a small company, you don't want to buy the very expensive software, okay? Then maybe some of those tools are just being very sophisticated, they also become very complicated. So maybe learning curve could be an issue, meaning that you have to first learn it, you have to start using it, you have to gain some experience using them, and then you can use them. So learning could be another thing. Other things that you have to look at when you're buying such a software is, number one, their ability to read from different sources. Are they able to read? Is this software has the ability to read with all major databases like Oracle and Microsoft SQL Server and MySQL and all those things, right? Can it read from these big data files, this JSON extensions, right? So all those things. So this is an important consideration to look at. Another one, how good this software is at it to automatically develop metadata. You remember metadata from the last time?
Yes.
Data about the data?
Yes.
Yeah, so all those things, these software should create very nice metadata for you. So you can look at that. Conforming to open standards. What is open standards? Open standards in software are those common rules that software follow. Okay? So if a software is developed on open standards, it is actually generally a good thing, because it means that it will work with many other software, because they are developed on common rules. Okay? So that could be an issue. Easy to use interface. I think you understand what that means. Is it like it has a complicated interface, or is it easy to use? Yes.
So user-friendly.
User-friendly. We are looking for. Now, when you're developing whatever structure, just a minor thing, it might be a little technical issue, so more interesting for computer science people. But when you're developing an architecture like this, would you like to go for what is called top-down approach or bottom-up approach? And this top-down, bottom-up approach is applicable not just in data warehousing and analytics. A top-down approach is meaning that you make the data warehouse first, and then you develop the data marts, because you start with the big thing and then you create the small things. But then bottom-up approach is, look, the actual users are data mart users. They are the ones. So if you create data warehouse, maybe you don't have data marts that the way you like, right? So another approach is you design data marts first, and then from there back you go up and see, what data warehouse I have to design, what do I need to keep in my data warehouse, right? You understand that? So which one is better? Well, the answer is you cannot say one is better than the other. It depends on your situation, depends on what you're facing, and I honestly cannot answer you that, because you need to have a lot of experience as a data warehouse designer, and then you will see for your company, for your situation, you will see that maybe one approach is better than the other. Okay, so it is very hard to tell beforehand that which approach works better. Okay, now one more option. Rather than designing the data warehouse yourself, is this the only option? No, there are more options. You don't have to create a data warehouse and spend a lot of money, a lot of effort to design and create your own data warehouse. There is an option of what you call hosted data warehouses. What is hosted data warehouses? These are shared. You can call it shared, but even something that you're more exposed to are like cloud, right? You're using clouds. All of you are using clouds these days. Even you can use Office 365 within the browser, right? So do you even bother installing, if you're using cloud, Office 365 using browser, you don't even are bothered whether you have like Office on your computer or not, right? You can go simply start using the cloud the next minute as soon as you have the subscription, right? So same concept. Rather than worrying about what will be the servers, how big capacities and all those things, one of the options is to go for hosted data warehouses. And these days, small to medium companies are looking for hosted data warehouses, because they are very easy to get. You don't have to worry about hiring technical people. You don't have to worry about many other things, So what are the benefits? You don't have to invest in creating infrastructure. When I say infrastructure, it means your servers, your computers, your hard disks, your networks, computer networks, that you need to support it, right? So infrastructure, so you don't need to worry about that. You're just using it, you're an end user. free up capacity on in-house systems. So again, you're relieving pressure on your IT, computers and everything, so that because everything goes there. Frees up cash flow. What does that mean? Now, if I wanted to create a data warehouse now, I have to buy some very expensive servers and many other things. Databases, I have to pay for Oracle license fees. You see that? I may have to invest maybe hundreds of thousands of reals so just to get my data warehouse started. But in subscription, like cloud services like that, I just pay a fee, a monthly fee or a yearly fee, right? And normally those fees are much cheaper. Why? Because they are working on such a big scale that they already have everything set up in there, they just charge a small fee. So, which means that you don't have to block a lot of big amount of your cash. You have to spend it, you can spend it somewhere else, right? So that cash flow, it improves your cash flow as well. Makes powerful solution affordable simply means that if you the same cloud concept, you can spend a little money and you get some very powerful softwares and some sophisticated systems that you can use. Enable solutions that provide for growth. This growth concept needs to be understood with the concept of something called scale. Growth, and I will just go, maybe grow, scale comes somewhere later. Scale. But let me just delay the discussion of growth for the time being. But basically you're saying that if your needs are growing, you have to grow with that, right? You have to improve your systems, you have to improve your computers, your hard disk, your scale, your size, everything has to be improved. I'll talk more about that when it comes to the topic called scalability. It is a little far, so I'll come back to it. But it basically says that when you go for hosted services, your growth becomes very easy. Offers better quality equipment and software and faster connection. So many good options come with the hosted data warehouses. Now, data warehouses are all about dimensional modeling. You remember from your database and our previous discussion about OLAP cube, the cube that we just showed. So different dimensions. So data warehouse, one of the main things that you're looking for using data warehouses, what you call dimensional modeling, right? So that's what data warehouses store. So just two terms, important terms for you to know about that. First of all, dimensional modeling helps you retrieve high volume queries, meaning that a query that accesses a lot of records. So you already have accessed that and created those cubes. So those results are already there, so that you can just look at the results directly. But star schema and snowflake schema are used in these dimensional models, and which basically looks something like this. So you have the main data that you're interested in, for example, sales data. But this sales data is analyzed around certain dimensions, as in the OLAP cube. These dimensions could be product. Sales of product A, sales of product B, sales of product C, right? A dimension. Another dimension is of geography, like sales of Eastern Province or Western Province or Central Province, right? Or sales done by salesperson A, B, C, D, right? So you're looking for performance. And then, it could be time. So this is called star structure. And mainly what you do is, you have the fact table, the data that you're interested in to analyze, like the sales data, right? And around it are all the dimensions that you're interested in. So data based on which dimension you want to look at what level. Okay, so these are called dimensions. And the next one is called snowflake schema. It is simply the extension of the same thing. So do you understand this one? If I can just add more detail to this one, then it's called snowflake. You can see here it's date, and then we can have months, quarters, and years, right? So it is just an extension of that. So this is how the data is organized. So multi-dimensionality. We are already saying that data warehouses, we are doing dimensional analysis, which means that we can have multiple dimensions on which we would like to analyze our data, right? So three things are important. Dimensions, number one, as I already told you, but other than dimensions, measures and time. Measure, what do we mean by that? So the same data, for example, sales data, we can be analyzing it based on product, based on salespeople, location, country, industry level. But then the same data measured on which scale, which measure? What does that mean? You can measure sales based on the number of products sold, right? Number of items sold. But you can measure the same sales data based on dollar amount or real amount. So sales could be 100 items sold, or sales could be sales, I have 100,000 real sold, right? So measure is something you have to pick. So the same data, maybe by finance people, they are interested in maybe like money. But for the supply chain people, they are actually interested in volume. So sales, so dimension is not the only thing important, measures are also very important. Plus a third thing which is very important is the time. You want to analyze this data on a daily basis, or monthly basis, or weekly basis, or yearly basis. So time is the third thing. So these are what you call multi-dimensional presentations. So you need to know three things, So all three things are important. We already have discussed OLTP and OLAP. So just comparing OLTP versus OLAP. But are you aware of these terms when doing OLAP analysis? Data slices, cubes, drill down, drill up, ad hoc reports. Are you aware of these terms? Maybe you have seen it, maybe not. So let's just see what those mean. So I'm sure you have seen those cubes, right? I've even shown you in one of the classes earlier, but in previous courses as well. So these cubes contains all possible information that you need about, for example, sales. Okay. Now what we need is how to get a particular data that we are looking for within this whole information represented by a cube. Okay. So to extract certain information, we might want to take what is called a slice out, right? Like a bread, you take a slice out, or you might want to take a dice out, not a slice out. Okay. I'm going to show you next screen what each one means. But a subset of a multidisciplinary, multidimensional array on a single dimension, most likely. Dice is more than 2 dimension. And then there's something called drill down and drill up. What does that mean? The two keywords here, and I'll show you on the next screen. One is drill down is about more detailed representation of the data, and drill up is more summarized data. Again, you may want to know more about it, so next screen I'll give you more examples about it. Okay, so it is drill up is summarized, drill down is more detailed, and roll up is a kind of a summarization. Are you aware of this term pivot or pivot? Have you done in Excel pivot tables? Are you able to do pivot tables? No. What you're doing here in OLAP cube can be done in Excel via pivot tables, pivot charts. Brothers, please, this is, if you are going for a job which you are not far from you, please learn pivot tables, pivot charts. Extremely important these days in jobs. Extremely important. The people say, do you know Excel? And you say yes. The next question they ask is about this. What I can do for you, if you haven't done it, I'll inshallah take maybe like a class and to show you how pivot tables and pivot charts work. But please do not go to a job interview and say that I know Excel, and the next time they say pivot table and you start looking at the roof. It will be very, very a bad thing to have. Pivot tables is from the entry level job to right up to the executive level jobs. Everyone these days are using these pivot tables and pivot charts. So I will make sure that I will cover that in this. Maybe I'll take one class off and just make sure you bring all your laptops in and see how those pivot tables, pivot charts work. Okay. But the concept of pivot is from there. Pivot is like the base. You know what is the basis of your data. So let's keep it for that class, and you will be able to see it better. But if you see there, you will be able to visualize the meaning of a slice or a dice or a drill down or a drill up better. So if you look at this cube first, so you have here what do you see here? Product 1, 2, 3, 4. And here in this direction you have what? Geography, meaning that like Eastern Province or Western Province or Riyadh, right? The area, geography. And in this direction you have time. Right? It could be month, week 1, week 2, period 1, period 2, period 3, right? Now, if you just wanted to take, you know, this one slice out about one particular product, analyzed based on areas and time. You see that we are taking this one slice out. This is called a slice. So I'm just analyzing one product, and I want you to analyze it based on area and time. Or I can do like here. So I can take different kinds of slices out. So slices look like this. Can you see a slice? I am taking a slice out. But I can also take a dice out, which means that not one product, but maybe a group of products analyzed for areas and you know, time. Right? So this becomes what you call a dice. You can see that it's not, because it's not one product, so you have like not like a paper, but you know, like a cube, a subcube. So this is called dice. But if you look at this slice, imagine this dice is, we are analyzing all products within Eastern Province over time. So what is drill down? The drill down is within Eastern Province. I'm going further deeper into not just Eastern Province, but cities within Eastern Province. So now I'm going from summarized, which is like the Eastern Province. The whole data is summarized for Eastern Province. Now I don't want summarized, I want details. Deeper, more details. So that's called drill down. So I'll be looking at, can you see that this cube is now converted into so many cubes? So it means that you know, those bigger categories or bigger areas are now cut into smaller pieces. Meaning that Dammam, Khubar, Dharan, you know, and all those things, and even within product categories we may have even sub-products and you know, all those things. Maybe here they were months, maybe here we are having like weeks or days, right? So drill down. The opposite one, as you can imagine, if you want to go from here back here, what do you call that? Drill up. That's the only thing. Drill up. Okay. And a roll up is as you can see, it's kind of, you know, summarizing based on one of the dimensions. So many different kinds of operations that you can perform. You can do slicing, dicing, you know. Pivot, I'll show you pivot charts, and then you will be able to understand it better, but it is like the basis of the data. Okay. Just few variations of OLAP. If you're running this OLAP over multi-dimensional databases, which is like the data warehouse, different data warehouses together, so we call it multi-M OLAP, multi-dimensional OLAP. But if you're running it over your normal database, relational database, we call it R OLAP. OLAP running on your regular database. So OLAP database on top of existing relational database. So you're running this OLAP operation on regular database, right? So it is regular database versus other thing. Then you can have, you know, some web OLAP and you know, OLAP services over web and so on. Okay. Any questions? Implementation issues. You remember one of the things I mentioned about hosted databases? What was that? Hosted database. I just mentioned that there is, rather than creating your own data warehouse, you can host it somewhere else. The cloud example, right? Yeah. Let me ask you a question. Do you think that it makes technical problems very easy, but it might create some other problems? So what are those? Can you think of some problems that can be created by hosting your data warehouse somewhere else?
Security. We need an internet to...
Okay, internet as well. Security, right? What do you mean by security? Your data is? Your data is somewhere else with someone else. Imagine Ministry of Interior data, Saudi Arabia, hosted in California. Do you think it's acceptable? It's very sensitive data, government data, right? The government is make sure that it is highly secured, right? So in such cases, what do you do? So we will discuss all those implementation issues. Okay. Of course, there can be solutions. The government can make. We'll talk about service level agreements and many things that the government say that no, this data, even if it is on a cloud, it should not be outside Saudi Arabia. The cloud has to be within the boundaries of Saudi Arabia, right? You understand that? So there can be issues, but we will talk about things like that. One of them, the topmost one, is called data governance. Who rules the data? Meaning what? Who is the owner of the data? Who is responsible for maintaining the data? Who has access to what data? Where the data has to be kept? Right? The ones that I just asked you. All these issues come under data governance. Data governance is an extremely important area these days. You go to a company and people talk about data governance. So you have to define everything. Who has access to what, who is responsible for what, who owns it, who can use it, who can be the user of what part of the data and everything. It comes under data governance. Another very important discussion these days is what you call data quality. And quality simply meaning that the data that goes in there will be the basis of your decision, right? Will be the basis of your analysis. So if something goes wrong, so you have to make sure that whatever data is going into data warehouse, it is correct. It is of what you need and correct information. So it should be complete and it should be correct. So all these correctness and completeness in issues come under data quality. And these are big areas, by the way. You have people who are just expert in data governance, you have people who are just expert in data quality. So you might end up doing a job just in data quality, or you might end up doing just a job dealing with data governance. Yeah, so don't think that these are small areas, these are big areas. The ETL tool that you wanted to buy, we already talked about that. Establishing service level agreements. I just talked to you about, if you're going for hosted one, so all those details, availability, pay for damages, where would you keep the data? Is it like outside the country or inside the country, right? And all those details have to be agreed. So there has to be like an agreement signed, and all those services that you expect from the company, so they go into an agreement called service level agreements. Data transport and conversion, we have already talked about that. But some of the other things is end user support, political issues. End user support meaning that if I face a problem, even those go into the agreements that how quickly even they have to respond to. I have been talking to some people in Alupco, this aluminum, one of my friends is telling me that they even have agreements saying that they have to respond within 6 hours. The IBM, I think IBM or something, is they have an agreement with, and they even say that they must respond with a user query within 6 hours, not like 24 hours. So they are bound by even with the speed with which they have to respond. Political issues, I already told that people are getting affected by your data warehousing decisions. So so sometimes those are important considerations. What things you should not do or avoid creating data warehouses? Sponsorship is a big concern. Why? Because data warehousing, whether hosted or you create your own, is not a small project. It is like a large high stake, large money project. So if your big boss is not on board and you try to do it on your own, your sponsorship problem will lead to its failure. So it must be sold first to your big bosses that this is what you wanted to do, not just me. Okay, the bosses are what really wanted to do. Sponsorship, expectations that cannot be met. Do not sell ideas that you cannot translate. So if you say this data warehouse can do magic, no, tell what it can do and what it cannot do. Okay, So it has to be expectations. Do not set expectations that you cannot meet. Politically naive behavior, we already talked about that. Loading the data warehouse with information just because it's available. No, keep only that data that you need to make sure that its performance stays, the way you like. Data warehouse design should be based on dimensional modeling, not on traditional databases, but otherwise it causes a lot of problem. This part is important, especially for MIS, keeping you as in consideration. You remember our discussion on computer science versus MIS discussion?
Yes.
The roles are different. Their role is technical. Their role is about coding and the technicalities of things. Your role is about knowing the business problem. You still know what they are doing, but your role is to think about users, think about business objectives to achieve, right? So if you make a data warehouse manager a technology-oriented person, usually it's a bad choice. It has to be a person because it's serving the users. So you remember in HCI, you have user-driven designs. You have taken HCI course, right? Human Computer Interaction course.
Yes.
So you design things for users. You don't design things and then give it to users. No, you don't do that. In HCI, you say you design for the users. Usability and user experience and all those things, right? So same thing here. You have to design data warehouse for users because they need those data in a particular form. So you're designing for them. So it has to, your manager has to be user oriented, who understands the problems of user, who understands how do I need to get information from the user, what do they need. So I think from this discussion you can identify where projects can fail. Bad sponsorship, your bosses are not on board. Don't go for a project where bosses are not on board because they will be the one paying the money and solving the problems. Okay, unclear business objectives, cultural issues. Sometimes people are used to working in a particular way, and the data warehouse, you need to change the way you work. So this is a very common issue in any, not just in data warehouse, in any information systems, ERP or anything you bring. People face this problem. And by the way, the solution is something called change management, which I hope that you have covered in one of your management courses. If not, change management is a methodology where you just next day don't say that this is the new thing that you have to do. You actually have a method to change people's mindset, you train them, you show them the advantages of it and so on, and then you slowly make them shift to the new ways of doing work. Okay, so this is called change management, and change management is an important thing for you to keep if you're bringing data warehousing.
So it's a way to avoid
Shock,
the resistance to change, right?
resistance to change. Because even if I showed you, suddenly you're using Oracle and I suddenly bring a new software, what would be your first reaction? You will reject it, right?
Yes.
So this is called resistance to change. You'll say, oh, why are you bringing this change? We are already working fine. How do we go and shift, right? Now, if there is a genuine reason for change, you don't bring change like this. The next day you have to use this. No, you don't force it. It will fail. So change management is a methodology in management which helps you deal with all these issues, with this resistance, and how can I make it work, going from point A to point B. The old ways of doing things and to the new ways of doing things, you apply the whole change, and it is by the way a sophisticated management approach. So you need people who are trained in change management, and they will help you go from this to this. So remember this thing, not just for data warehousing, for anything that new you're bringing in your company, just remember only one name, change management. Because you can always find a person who can help you do change management. Okay? But change management is an important. Unrealistic expectation can lead to failures, inappropriate design, low data quality, of course, can lead you to failure, and the speed and architecture. Now you remember I talked about growth. I said I'll come back to this growth thing. Whenever you're talking about not just data warehousing but any IT issue, information systems or information technology issue, one problem is very important to all companies, all managers, and this is called scalability problem. So what is scalability problem? So you know that whenever we are dealing with something, we design this solution for today, right? For example, if right now imagine I start a new university and we have like 500 students. So my SIS is designed to handle 500 students, but I don't think I'll stay 500 students, right? I expect this to grow. My internet capacity, my data warehouse size, my database, my hard disk, my computer powers, right? They all will not be sufficient after maybe even 1 year, right? So scaling means I design a system that scale with the scale of my problem. Scaling means you change your size. You understand what is scaling? Scaling means changing size. So scaling your systems meaning that my system grow as the problem grow. Everybody understands scalability? Now I want you to go and look at the video by Google, and if I can find that, I can share that on our group, where they are showing how they are maintaining their cloud systems. What they are doing is a concept they are using called hot plugins. Hot plugin meaning that if this computer is not sufficient for my work, what normally I do, I just go and buy a new computer more powerful, right? And then I take days to shift my data and all those things. What they do is they cannot afford a thing like that. When the Google servers are no more powerful enough, they cannot just turn off and then bring for 6 months, new systems. What they do is while running the system, they add elements to this system. So one processor, they add another processor to it. The systems are designed like that. If their two processors are not enough, they add a third one. They have like racks. So their hard disk is not enough. They just buy a new hard disk and then they plug. Hot plugin means the system is running, they don't even turn off. They add one more hard disk. But this is for normal companies. For Google, they even add servers. They plug in a new server. They add one more server. They add one more server. They add one more big hard disk, right? You understand how it's working. So what they are doing there is scaling their systems so that it meets the requirements of their customers. So scaling is a big issue when it comes to not just data warehousing, but any information system. So what is the issue of scalability? The amount is changing. The data warehouse you keep adding the data. So how quickly you need to know how quickly you expect this data warehouse to grow. So what do? Maybe the number of users might grow, right? Maybe it was used by 5 people now, then 50 people, then 500 people. So what do you do with that? Maybe the queries become more complex. So good scale systems are the ones that grow with the problem. So as the problem is growing, you make your system grow as well. And this is why, by the way, hosted databases are very good because they are already growing. That's the only thing they are doing. So they keep adding resources to their system, so their systems also grow. Okay. I think one or two last few important topics left. Real-time data warehousing we already talked in the last lecture. Real-time meaning that data warehouse normally it deals with historical data, but modern data warehouses, they say now the systems are becoming more powerful. We do not need only historical data. We want real-time data, meaning that exactly now what is going on, I need to look at the data. So they call it normally active data warehouse or active BI. They call it what? The term that they are using these days is called active data warehouse and active BI. So we have traditional BI and traditional data warehouse and active ones. Okay. So the idea is enabling real-time data updates for real-time analysis and real-time decision making. We already discussed that. Real-time is the key. It can be push and pull systems are where you want to get the information comes to you, pushed to you. But one of the concepts that I forgot to mention last time, where we were discussing that. okay, maybe it wasn't mentioned here, but okay, let me come back to it. Okay, so one of the things when you're working on data warehouses is to get reports. Okay, this is typically what you do because you have the data. Every time you get a report, I want every week I need a report on my sales. Do you all agree with that? You understand what I'm saying? As a manager, I want to have reports for my each region. Report. Now these reports are called batch reports or regular reports. Batch reports simply meaning that I have report for Eastern Province, I have a report for Western, so I ask them to produce all those reports in a batch. Okay, but these reports are usually built on historical data, the previous data that you already have. But when it comes to real-time or active data warehouse or active BI, there is a change in the way you are using data warehouses, and now there's an increase in, you can see some increase in ad hoc reports. So what are ad hoc reports? What do we mean by ad hoc? Do you know the word ad hoc? Have you used ad hoc before? Ad hoc is a Latin word which basically means that as per need. So whenever there is a need, you do something, not on regular basis. Now the regular reports are produced every week. You understand that? Now I face a problem that I haven't faced before. So I am asking you can you dig in the data, a specific new kind of a report to dig just for now? You understand that? That's an ad hoc report. So it's not a regular report. An ad hoc report later can become a regular report if you're just asking it to produce every time.
Something
Requested upon. Whenever you need. And usually these are like special situations, right? You don't ask for them on regular basis. So these are called ad hoc reports. Now in real time, you are looking at problems as they arise. So many times you see something in the data that what is going on. So you ask, can you please dig in the data and produce this report? Now you are not asking them on regular basis, like give it to me on every week, right? So real time. One of the changes that is happening with real-time or active data warehouse is that it used to be very few ad hoc reports. It was mostly batch reports, regular reports. But now there is a huge increase in ad hoc analysis because you can see more problems and you can have more questions in your mind and you can produce more reports on it, right? So these are called ad hoc reports. I hope you understand the meaning of ad hoc. Ad hoc, by the way, is used in many different senses. So just for your general knowledge, we can have in College of Business, you can have in your student club an ad hoc committee. So what is ad hoc committee? In your student club, you have some regular committee works, right? If you're working for student clubs, you may have an information committee, you may have like a finance committee, right? That does regular job. But then you create an event. You have an event. And just for that event, you create a committee. You understand that? That's like an ad hoc committee, just you create it for that, for a specific purpose, right? So ad hoc is not just restricted to report, it can be for anything. Ad hoc committee, ad hoc work, ad hoc report, anything that you don't do on regular basis, but you request for it, on a temporary special basis. Then, of course, another thing that is happening is with this change, evolution, more, you remember analytics, this is where we go to the start, prediction. Again, this is increasing what is happening now, more sensitive query, real time, so all these things are happening with these modern things. This is just a case, so I'll not go in there, it is just an example for how a particular company has set up. So what is the difference between traditional warehouse and active data warehouse? Active warehouse were only strategic in nature. You are just looking for long-term historical data. But now in real time, because you can see real time, so immediate problems can be looked at. Now I'm facing a problem, so I'm just interested in solving the current problem. So now it's no more strategic, but data warehouses are trying to solve not just strategic problem, but tactical problems as well. Results sometimes are hard to measure, results measured with operations, again, operations meaning like real time. Previously it used to be on daily, weekly and monthly basis. Now you can be maybe looking at it at much smaller resolution, even on minute basis and so on. You know, much higher resolution. This is one change. Number of users, moderate user concurrency. Concurrency simply meaning in IT language and computer language, concurrency means concurrent means together. User concurrency means how many users are connecting to your system at one time.
Simultaneously.
Simultaneously, a better word is simultaneous connections, right? So when it used to be traditional data warehouses, the user concurrency was low because only managers were connecting to it. Now operational level staff is also accessing data warehouses because you have real-time information. So the concurrency level is going high numbers, thousands even at times to the data warehouses. Okay. Usually highly restrictive batch reports were there. Now systems have to be designed for more ad hoc reports. Basically saying that flexible ad hoc reporting is now part of the system. So you have to design your system which allows ad hoc reporting and can be used by different people. Okay. We already talked about administration and security issues a little bit, right? So safeguards have to be put. Few more things. The person basically saying that the administrator should be knowledgeable, have good communication skills, etc. But I think this point is very important. Security issues is not like you think about company alone, but even now government regulations have to be met when you're creating data warehouses and databases, so that what government of Saudi Arabia says that this must be the security measures you have taken before we approve. Right, so there are even some regulations. This is maybe a US regulation, HIPAA, but there must be an equivalent here in Saudi Arabia, where you just need to be aware of those. Okay, and that's it. Future, I think we can imagine that sources can be more varied. It's not just the databases. Sources in data warehouses can be web, social media, big data. Are you aware of this term SaaS, software as a service? You all are using this.
Yes.
If you use Office 365 within browser, not the desktop app, you're using SaaS, software as a service, meaning that you have not bought the software, but you are just you call that software as a service because you're running it through browser. So any software running through browser, we call it software as a service because you're not installing it on your system. Cloud computing, we already talked about that. I think the rest we have already talked about that. So this is it for data warehousing. Now, one thing before we stop and leave. You have a question? Okay. Our quiz will be on 20th of February. So I just wanted to remind. It will be multiple choice questions.